Hello everyone, +2 here. We're doing level 1, 91947 demonstrate mathematical reasoning. So this is algebra plus geometric reasoning. Right, let's see question 1. So I'm gonna finish question 1 and have a rest and to question 2 and 3. All right. So question 1a, the diagram below shows a cuboid. Find the total surface area of this box given that x equals 7. Right, there are two ways to solve it. You can make an expression of surface area in terms of x, and then you plug 7 into it at the end. But I think we just plug them in and find dimensions first, and hence find the surface area is easier. So if you plug 7 into this expression, what do you get? 13, right? And this is 23, and this is 21. So surface area means, as you know, 2 times, I'm gonna start at bottom and top. So when I make a 13 times 23, automatically it doubles because I said 2 times. And then I plus side. So 13 times 21. Oh, I mean front and back. So front is a 13 times 21, and then size, so which is a 23 times 21. Easy. So you plug those numbers in, you will get 2110. I don't think you have a unit, so well, you can say units squared because it's area. Should be the answer. All right, next question. Question B. The graph below shows two straight lines with equations 3x minus y equals 2 and x plus 3y equals 19. The lines intersect at the point Q, right? Find the coordinates of the Q using the algebraic method. So it's solving simultaneous equations, right? So I see the second equation, x plus 3y equals 19, can be rewritten to x equals 19 take away 3y, right? And then what we do, we plug this into the first equation. So I say 3 times, instead of x, I say 19 minus 3y minus y equals 2. Why am I doing this? To eliminate x, isn't it? So now it's everything about y. So when I expand this, hold on. So this is the equation we are solving this. So 3 times 19, 57 minus 9y minus y equals 57 minus 10y. So that is 2. So that means 10y equals 55. Hence, y must be 5.5. So once you know y value, so back to this equation, x equals 19 minus 3y. So you plug that into the equation. Hence, x equals 19 take away 16.5, which is 2.5. So you can leave it like this, or kindly say q bracket 2 comma 5, which is x value, comma 5 comma 5 should be the answer. All right, next question C. The diagram below shows a rectangle ABCE. Length AE is 70 centimeters. Length AB equals 1.2 meters. Angle CBD is 28 degrees. Find the parameter of triangle BDE. So BDE is this. So I'm gonna just mark. So say this, that, and that. So we add these 3, isn't it? So now, and you see, we have to unify the units. So one is meters, the other one is centimeters. I'm gonna change to meters, right? So 70 centimeters is how much? 0.7 meters. Right. So I see, first of all, when you see this triangle, right angle triangle, I see a BE. So I need a BE, right? So BE is hypotenuse of the right angle triangle. So that means square root of 1.2 squared plus zero point 0.7 squared, right? So that gives me 1.39 meters. So I'm gonna make a 2dp all the way. So then I see from this triangle, I can find the BD, right? So use cosine because that side is 0.7. So I can say 0.7 over BD equals cosine 28 degrees. So hence BD equals 0.7 over cosine 20. That gives me 0.79 meters, right? And so I got this and that, and I need a ED. I don't think I can find the ED straight, but what about if I find the DC? Then I can take that away from 1.2, right? So find the CD first. So I can say CD over zero point 0.7. So I'm still using this triangle, okay? Using trig. So equals 10, 28. So hence CD equals 0.7, 10, 28, which gives me 0.37. I need this for DE, isn't it? So hence DE equals 1.2 take away 0.37, which gives me 0.83 meters. So I need these three add up to, so I say the parameter equals add up to 3.01 meters. All right, that was easy. Oh yeah, question D. This was a bit challenging question, I reckon, because I expected, to be honest, uh, quadratic equation, but it turns out not. So I'll show you what this is. So first of all you have to do, always you find the difference. So expect common difference, right? So what is it? 18, right? So I'm saying 29 take away 11 is 18, and 29, 18, 83 take away 29 is a 54. So obviously it's not common difference, so it's not linear. 245 take away 83 is 162, and 731 take away 245 is 486. Then what I did is I found common difference between differences. So that is a 36 and 108, and then this is 324. Obviously, it's not common difference, right? Yeah. So a bit upset, but then I found, so this one didn't work. Do you see 54 divided by 18 gives you 3, and 162 divided by 54 is a 3 as well. So I'm saying 18 times by 3 is 54. 43 times by 3 is 162. And 162 times by 3 is 463. This gives me the idea of exponential graph. So it is exponential equation. Okay. So, well, what you have to do is this. Um, you have to find this rule. So say y x equals a times a to the power of x plus b. So this is a common kind of a equation formula for exponential. Okay, so here a is the common ratio. So in this case, a 3, right? And a, this big A and B, they are constant. So we have to find it out. So obviously we need at least two equations to find A and B. So watch this. Say, yeah, first of all, we know A is the small a, common ratio is a 3, right? So I can say yx equals A times 3 to the power of x plus b. We start from there, right? And then what it means here, yx is like when x is 1. So because x is pattern number, right? Equals A times 3 to the power of 1, isn't it? Plus b, and y1 is actually 11. So, well, if I rewrite this, 3a plus b equals 11. That's the first equation. And I use a second equation. So when x is 2, so that means a times 3 squared, isn't it? Which is 9 plus b equals 29. So if I write it 9 first, so 9a plus b equals 29. So that's the second equation. So from here, so solving simultaneous equations, isn't it? So I take away from bottom to top. So that gives me 6a equals 18. So hence a is 3, right? Because a is 3, what is b? I can use the equation number 1. So if I plug 3 into there, so 3 times 3 is 9 plus b equals 11. Hence b is 2, right? So a is 3, b is 2. Hence the equation is, the formula is a is 3, right? So 3 times 3 to the power of x, I can, simplify 3 to the power of x plus 1, isn't it? Do you know what I'm saying? A is 3, so 3 times 3 to the power of x is 3 to the power of x plus 1 and plus 2. And then what? We have to test whether it works. So when x is 1, 3 squared, 9 plus 2, 11. Very good. I'm going to use red. So the first one worked. And second one, when I plug 2 into x, so 3 to 3 cubed, which is 27, plus 2, which is 29. It works. And let's jump to fifths. So if I go y5, 3 to the power of 6 plus 2, isn't it? So I'm going to say, because 3 to the power of 4 is 81. 3, I'm just going to go this. Yes, it is 731. So it works. Okay, so that is the equation. Okay, so you could write like this. Yeah. Probably I will rub this out. So y equals 3 to the power of x plus 1 plus 2. Looks better. Okay, next. The graph of y could be drawn for all values of x. Identify 3 different features of the graph of y using your equation found in part D1. You may choose to use the set of x's below if it helps you. Feature 1, 2, 3. All right. So I would say feature 1 would be it is exponential, right? So before we do, let's draw this. So I'm gonna rewrite the equation, which is y equals what? 3 to the power of x plus 1 plus 2, wasn't it? Yep. So here, because of it's a plus 2, we have this asymptote, horizontal asymptote here. So I would put that dot. So the equation would above y equals 2. Okay, and because this is a 3 to the power of x plus 1, I could tell when x is negative 1, y value is 1. Okay, so I would draw a line here, dotted line, and then I draw. Oh, by the way, when x is 0, what do you get? When x is 0, 3 plus 2, which is 5. So I know this is 5. And what else? Do you remember when x is 5, how much was it? 731. It's a big number. It's over there. So I would draw like this. Oh, hold on. When x is negative 1, that's 3, isn't it? So I will make sure. Try again. So with this pattern, I draw really steep, maybe steeper. So like this. So remember, like when x is 5, it was like 700 something. So it's like up there. That should be that should do. So the few features first, I would say this is an exponential graph, and feature 2 would be the horizontal asymptote, p tot is y equals 2, because y equals 3x to the power x plus 1, 3 to the power of x plus 1 plus 2. So because of this, yeah. Right, I will explain what asymptote is. So over there, so if you see like a minus x value is minus like a million, it's not 2 yet. It is so close to y equals 2, but it's not. So this graph doesn't touch y equals 2. So that's called asymptote. And now the third one would be y-intercept I can talk about. So y-intercept is 0,5. So at x equals negative 1, y value equals is 3. Yeah, these 3 would do. All right. So this is the end of question 1. All right. I will see you next time. Bye.